name is Eric Danheiser. I'm headed into my senior year at Alfred State College in the electrical engineering program. This past semester, I found an area of my major that really caught my interest, and it's something I can see myself pursuing in the future as a career. That something is integrated circuit design. Integrated circuits can also be called ICs, and you may be hearing me say that throughout the presentation. The process that I'm going to describe is known as the PMOS process, and this is how they are made. PMOS stands for P-type metal oxide substrate. But first, what exactly is an IC? Well, simply put, ICs are tiny chips that do specific tasks and are found in just about every electronic device there is. From cell phones, iPods, computers, televisions, even a TV remote has an IC in it. And for me, being an electrical engineering program and using ICs for the past 3 years, I had always wondered how IC designers were able to make such complicated circuits using hundreds, thousands, even millions, and in the near future, billions of components on incredibly small surfaces, no larger than your fingernail. And it's through the PMOS process. And this is how it begins. You use a flat, round piece of silicone. And on a piece of silicone, you can have up to hundreds of chips, different types, for all different tasks. The next step is to hot probe test the wafer. This is the PMOS process. You want it to be P-type, which means positive. If the entire wafer is not positive, then it's a defective wafer and you cannot use it for this process. After that, you have to RCA clean the wafer. RCA cleaning consists of two different types of solutions, APM and HPM. The APM solution is water, ammonium hydroxide, and hydrogen peroxide. The HPM solution consists of water, hydrochloric acid, and hydrogen peroxide. Once the wafer is nice and clean, it's time to go into the oven for an oven run. And in the oven, it grows 500 angstroms, or 0.5 microns, of oxide on it. The next part of the process is known as lithography, and lithography is done 4 different times during this entire process. Lithography is the process of developing photoresist on a wafer which has a mask of an IC layout on it. Once the photoresist has been developed, you then oxide etch the wafer. It is very important to remember that after you oxide etch it, you get the remaining photoresist off. And this is done through the use of acetone and another clean known as Koronaclean. Koronaclean is a solution consisting of hydrogen peroxide and sulfuric acid. And it gets the remaining photoresist off that the acetone did not. Once again, it's back into an RCA clean. And after that, back into the oven. This time for boron diffusion. Next in the PMOS process was to etch off the oxide using borosilicate etch. This was done to expose the boron that was just diffused into the wafer. Once again, after this came an RCA clean again and another oven run, this time for what is known as field oxide, another 5,000 angstroms of oxide. Next part was layer 2 lithography. Now every part of lithography has a different mask. This is for each different part of the component that's in each chip. And you have to line it up perfectly on top of the last layer that you just did. Once again, after that, you oxide etch it, get off the remaining photoresist with acetone and Koronaclean, then RCA clean again, back into the oven once again, this time for thin oxide, 700 angstroms, or 0.07 microns of oxide. Then it was time for layer 3 lithography. Layer 3 lithography is known as the contact cut mask. And the contact cut mask is where the wires are going to be attached to each individual circuit. Same process as layer 2 and layer 1. After you do lithography, you oxide etch it, get off the remaining photoresist. But instead of going into the oven, you have to dip it into a hydrochloric acid dip for 1 minute to prepare for aluminum deposition. Aluminum deposition is the most interesting part that I found in this entire process. A piece of aluminum is put on a coil that is heated up to an incredibly high temperature, and it's in a vacuum-sealed container. When the aluminum evaporates, it goes up and attaches itself to the silicone wafers suspended above it. This is also how mirrors are made, because after you take them out, it has a very shiny layer on it that you can see yourself in. Next came the final step, layer foil lithography. And once again, it was very easy. Just put the photoresist on, put the mask on, take off the photoresist, but this time you don't oxide etch it, you metal etch it. Metal etching takes about 10 seconds. Just like that, metal is gone, and it just has your remaining circuits on it. The final step is the sinter run. The sinter run is another oven run, and it just makes sure everything's set in place and is ready for distribution. From there, you test each chip. And if you have a bad one, you're obviously not going to use that chip. Then carefully, you have to cut out each individual chip from the wafer. And like I said, they're no bigger than your fingernail, so this could be a very touchy process and you don't want to make a mistake in there. Once that is done, each individual chip is put into its own casing with golden thin wire on it, and it's ready for distribution and ready to be used out in the field. Thank you.